Alright, this is test review number 3, and I'm working on 8, 9, and 10, and these are order of operations. And of course we'll be applying fractions to these order of operation problems. Alright, so number 8, first of all we look at our PEMDAS, which is a little mnemonic to help us remember what the order of operations is, which is parentheses, exponent, square root, multiplication, division, adding, subtracting. When I write it out this way, exponent, square root on top of each other, I do that because they're really done at the same time, and then multiplication, division at the same time, adding, subtracting. But it's probably just easier to read it horizontally. Okay, so as we work our way down, we do our parentheses first as we go across. Is there parentheses? Yes. So we do those first. And when we add these two fractions, they already have a common denominator, so we don't have to find one. And so we're just adding the numerators. 2 plus 1 is 3. And of course we don't add the denominators. We just put that there. And then we bring down all the other components of the problem and work on the next line. Multiplication sign, and then 4/3, which gives us line 2. This is our first line. So now we're going to work on this line, and it's multiplication. So remember, with multiplication you multiply numerators and denominators. If the denominators are the same, it doesn't matter, you still multiply them. So can we use cross cancelization? Of course we can. 3 goes into 3 once, 3 goes into 3 once, so we really have 1 times 4 is 4/3. So the answer just turns out to be 4/3. Now it says simplify the expression in the directions. I would take that to mean don't leave it as an improper fraction, make it a mixed fraction. So always, to be safe, break something down as much as you can. So 3 into 4, we have 1 and 1/3. So the answer comes out 4/3 is 1 and 1/3. And that's the answer to number 8. So we just change that improper fraction to that mixed fraction. Alright, so I moved our problem so this was stacked, and then I can work on this problem. So let's work on problem 9. So let's look at our order of operations. Are there parentheses or brackets? No. Are there exponents or square roots? Exponents or square roots? Yes, there are. So we do the exponent first. So let's solve that. Remember that 3 squared is 3 times 3, because the exponent means multiply by the number of, by itself twice. 3 times 3. And that's 9. So we have a 9 here. And we're starting our line 2. This is our line 1. We work this way. So I'm going to bring down the rest of the problem. And that's bringing down the multiplication sign and the number, subtraction sign, as well as the fraction. So 9 times, and the minus sign, and now the fraction. Okay, now I go across this way. This is line 2. I look at my order of operations. Do I have a parenthesis or bracket? No. Do I have an exponent or a square root? No. Do I have a multiplication or division? Yes, I do. And I go left to right. Multiplication comes first, so we do that. So 9 times 9 is 81. And that begins our line 3. And we bring down the other parts of the problem, this subtraction sign, this fraction sign. Okay, so then we look at the problem this way. Okay, now we have this problem 81 minus 5/9. So we're going to have to borrow to create a fraction. And let's make this a vertical problem so it's a little easier to work with. So we're going to our next step. I'm going to make it a vertical problem. 81 minus, and then 5/9. We can subtract 0 from 81, but we cannot subtract 0, this 5/9 from 0. It doesn't work. So we have to borrow from the whole number. And borrowing from a whole number means if you have 81 whole pieces, and if I were to draw 81 dots, which I'm not going to do, you would imagine 81 dots drawn, we're going to borrow from one of those dots, which really means we're going to take that dot and we're going to chop it up into pieces so we can make it a fraction. Well, how do you make any whole thing into a fraction? You just cut it. If you're cutting it into pieces but it's still 1, you simply call it, in this case, 4/4. But we wouldn't want to make a whole piece into a fraction of 4/4 and then have a different denominator. That doesn't make sense. We want to make it have the same denominator. So what we'll do is we'll take one piece out of the 81, that makes it 80. Take that one piece and we're going to cut it up into 9ths so we automatically have a whole piece cut up into the right number of pieces. Whoops, that should be the number 80. So that we have a fraction with the common denominator of the one that we need to subtract from. So, and you're going to see me do this several times. There's a lot of examples on this review sheet where we're going to be borrowing. So we've got the 0 and the 5/9. You don't have to write in the 0, that's not necessary. And you're subtracting because you want to make sure you don't forget the function that you're doing. And now you can do the subtraction because you have a whole number that you can subtract from this numerator. And you do understand that 9/9 equals 1 because any number over itself equals 1. So if you added 1 back to 80, you'd get 81. So we just split it apart. So 9 minus 5 is 4. You have 4/9, squeezing it in. And 80 minus 0 is 80. So our answer, let's put it up here, 80 and 4/9. And 4/9 is a reduced fraction, so we don't have to do anything more to it. So 80 and 4/9 is the answer to number 9. Okay, we're working on problem 10. So we look at our order of operations. Do we have parentheses? No. Do we have exponents or square roots? No. Do we have multiplication or division? Yes, we have multiplication here and here. Well, we go left to right, so let's do this multiplication first and then this multiplication. So I'm going to take this first, and I'll do that. I'm going to bring down the adding sign. And then I'm going to do, and you can do this in a problem that's arranged like this. You can go ahead and do those two at the same time. So remember, with multiplication, you multiply the numerators. 1 times 1 is 1. Multiply the denominators. 2 times 2 is 4. 1/4 plus 1 times 1 is 1. 7 times 2 is 14. Alright, now we're adding these. We cannot add these without having a common denominator. They're both even numbers, so that at least makes it a little easier. So let's take the larger number and look at, because 4 doesn't go into 14. So 4 times 1 doesn't work. So let's look at or 14 times 1 doesn't work. So let's look at 14 times 2, which is 28. So you're kind of looking at multiples. Well, you are looking at multiples here. And we'll be going over multiples and least common multiple, which is what you're finding. So the least common multiple between 4 and 14 is 28. So you're going to be changing this and this to a denominator of 28. So 4 times 7, and so we have to multiply that by 7. 14 times 2, and then we multiply the numerator by 2. So this is changing our denominators so that they equal 28. So that makes this one four times 7 is 28. 1 times 7 is 7. Make sure you're carrying down that plus sign. And 14 times 2 is 28. 1 times 2 is 2. Now we can add those numerators because we have a common denominator. 7 plus 2 is 9. So you have 9. Well, let's keep our arrows there. We're adding these two. We're going to get 9 28ths. 28 is not divisible by 3. 9 is. 28 is divisible by 2, but 9 is not. So 9 28ths is already reduced. So the answer to this problem is 9 28ths, and that is problem 10. So the answer to problem 8 is 1 1/3. To problem 9 is 80 4/9. Problem 10 is 9 28ths.